Hi, welcome back. Hononegah Honors, Algebra 2. Section 10.1. Chapter 10 is all about statistical analysis. And so you're dealing with probability, things like that. So we're going way off to the other side here as far as mathematics is concerned. Let's talk about an experiment. Experiment is a controlled operation that yields results. So when I'm looking at, and I'm going to skip down to experimental probability, that's the actual occurrences the actual observations of the trials of an experiment. Theoretical probability, going all the way to the bottom, is in theory what should happen. So if I was looking at a deck of cards, what is the likelihood that I will pick a card and I'm going to end up getting an ace? So there's 4 aces in a deck, 52 cards. The theoretical probability is 4 out of 52, and I can reduce that. But that is theoretical probability. Outcomes, going all the way back up at the top, is the possible results of an experiment. Again, these are all the different ways that something could occur. So again, there's 52 cards. I could, in theory, draw any of the 52 cards in my first draw. Sample space is a list of all the possible outcomes, and that's going to be our first question, just listing all the different ways that something could happen. So you spin a spinner and then flip a coin. And by the way, it's a two-sided coin, heads and tails. How many possible outcomes are in the sample space? List them. So I could get blue, I could get yellow, I could get um, red, and I could get green. Now, I like to do a little chart here, but that technically isn't the list. So if I did blue, then I could also get a heads and then a tails. And a yellow, I could get a heads and then a tails. Heads and then a tail, and then a heads and a tail. So the actual list, though, is listing out all of the possibilities here. So blue with the heads, blue with the tail. Yellow with a head, and yellow with a tail. Red with the heads, red with a tail, and green with green with the head and green with the tail. So those are the 8 possible outcomes that if you spun this particular spinner that has 4 spaces on the spinner and flipped a two-sided coin, you could get. Theoretical probability, the probability of an event occurring, or the likelihood, the chance that an event occurring. The probability is the number between 0 and 1. It's a percent. It can be written as a percent, it can be written as a decimal, or it can be written as a fraction. So impossible has a 0% chance. So the likelihood of me making it into the NFL has a 0% chance. Impossible. Certain, that is a 100% chance. So again, something that will happen for sure, that has a 100% chance. The outcomes of a specified event are called the favorable outcomes. So when you put a fraction together for a theoretical probability, the number of favorable outcomes go on top and the total number of outcomes go on bottom. So the probability of event A is written as P of A. So this is the little notation that you write. So the probability of A. So P of A. So the number of outcomes that are favorable compared to the number of total outcomes that there are. A student taking a quiz randomly guesses the answers to 4 true-false questions. So let's talk about how many different ways you could do these 4. He could be correct or they could be incorrect. Then the next question, he could be correct or incorrect. Correct, incorrect, correct, incorrect. And then the last question, correct or incorrect, incorrect. And I know this is a lot of C's and I's here, but I'm trying to give you an indication. So now, looking at the bottom, that'll tell you how many are. So they have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 possible outcomes. For example, I could get correct on all 4. So circling it, this is one possible outcome. So I'm looking at the tree going down. So it could be correct, 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 and then incorrect. That would be another one. Or correct, correct, incorrect, incorrect again, and so on. So what is the probability of a student guessing exactly 2 answers right? So I'm going to get rid of my circle here and put those C's back in. So that was correct and incorrect. All right. So 2 exact answers. So I'm just going to kind of 2 correct, and then the rest incorrect. So there's one possibility. Correct, incorrect, correct, but then incorrect again. Incorrect, 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 and correct. So on this side over here, there are 3 ways that you could actually get 2 correct answers. On the other side, incorrect with 2 corrects and an incorrect. Incorrect, correct, incorrect, correct, incorrect, incorrect, and so now the only way is there. So there's 3 on this side as well. And so there are a total of 6 favorable outcomes here. 6 times in this particular chart that you had exactly 2 correct. So there is a 3/8. Now, you also could write that as a decimal. You could also write that as a percent. So 3/8 is a 0.375. And to be honest, most people, when you start talking about probability, prefer things as a percent. 3 out of 8 is pretty good, just ultimately because you're saying, okay, if I tried this 8 times, I got 4 questions, I'm going to randomly guess, I'm going to try it 8 times, 3 times I'm going to get 2 right. But a lot of people, again, prefer to say 37.5% of the time I will get 2 correct. So in other words, guessing is not good since 2 out of 4 is a 50% F. The sum of the probabilities of all the outcomes in the space is 1. Therefore, when you know the probability of an event, you can also find the probability of the complement of event, meaning when the event does not occur. A consists of all the outcomes that are not A and is denoted by an A with a line over the top. So the notation A with a line over the top is read as A bar. You can use the following formula to find probability of A. So 1 minus the probability of A would be the probability of A bar. Let's think about this. If the probability of me going home and eating dinner with my family has an 80% chance, then the probability of me not going home and having dinner with my family is 20%. So the probability that one event occurs, and the difference is the probability that the event does not occur. Find the probability of each event when 2 six-sided dice are rolled. So the probability of getting a roll that's greater than 7. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 positive outcomes for this out of the grand total of 36 total outcomes. So when you roll the dice, there's 36 different ways. So if I reduce this, and again, you should reduce all fractions or turn it into percentage. If I reduce this, it's 5/12, meaning if I rolled the dice 12 times, 5 of those times I should get a roll that's greater than 7. Now, what is the probability of not a 10? Well, first, let's find the probability that you get a 10. So 3 out of the 36 rolls is 10. So not getting a 10, the other side of that is 33 out of 36 rolls. So that is 11 12s. And again, reduce the fraction when doing a probability as a fraction, otherwise turning into a decimal or a percent. You throw a dart. Now, this one is on the test, and I'm not going to lie to you, this is a little bit confusing for a lot of people, but you throw a dart at the dartboard shown. You are equally likely to hit any point inside the square. What is the probability that the dart lands in one of the 2 yellow sectors in the smaller circle? So really, success here is if I land, and I shouldn't have used red probably, land in the 2 yellow sectors in the smaller half. Find the area of the entire dartboard, because that's the total, and then find the area of a favorable outcome. So now it's 5 across here, 5 here, 5 here, 5 here. So the dartboard has an area of 100. So that is the total area of the dartboard. Now let's find just the area of the circle that I consider to be a favorable outcome. Area of a circle is pi r squared. So the area of that whole circle here is 4 pi. And so the area of just half the circle would be 2 pi. So we're talking about a favorable outcome of 2 pi. divided by 100. So now let's actually find what 2 pi is. 3.14 times 2 would be 6.28 divided by 100 would be 0.0628, or 6.28% probability that if you threw a dart randomly and you are going to hit the dartboard, you have a 6.28% chance that you will actually hit in the yellow portion in the inner circle. Experimental probability, that's a little bit different. Now you're not talking about theory anymore. You're talking about I actually did some trials. I tried this a number of times, and the number of trials is the number of times the probability experiment is performed. Each trial that gets me a favorable outcome is on top. So it's success over total number of times that I did it. So the experimental probability can be found using the following. Each section of the spinner is shown at the same area. The spinner is spun 20 times, and the table shows the results. So the total number of times the spinner was spun was 20. That's the total. For which color is the experimental probability and stopping on the color the same as the theoretical probability? So what should happen here? If I spin this 20 times, in theory, I should get 5 on each one. In theory, right? Because I have an equal number of chances to get green, yellow, blue, or red. So the 5 out of 20. So which one is the theory the same as the experimental, and it's red? In the United States, a survey of 2,184 adults age 18 and over found that 1,320 of them have at least one pet. The types of pets in the adults are shown in the figure. What is the probability that a pet-owning adult, so be careful here. So it's got to be the pet-owning adult, not the total number surveyed. So of the 1,328 people that do own a pet, what is the chances of actually getting somebody that owns a dog? So we got a 916 out of 1,328. Again, please make sure that you reduce all fractions. Even though that answer is correct, I will take a point off for not reducing the fraction. So it should be 229 out of 332 as a reduced fraction. Now, if you turn it into a decimal, fine. If you turn it into turn it into a percent, fine. But if you're going to leave it as a fraction, you need it as a reduced fraction. Your homework assignment, we're back out of the book. So we're off the worksheet train that we've been on recently. And so back out of the book. So on page 542, if you have any questions, please make sure you talk to your teacher, and good luck.